Okay, so now that you've started it, we're going to go over it. Is that your question? No.
No, you can do it.
Okay. All right, so the directions say use the definition of the limit. So my hint to you is I give you the equation. Use it. Don't plug into something else. Use this. I gave it to you. All right. So negative 2 minus x squared at x equals a. So I want to find the derivative of, let's see, at x equals 3, right? At a equals 3. So my derivative at 3 is going to be the limit as x approaches 3 of f of x minus f of 3 all over x minus 3. All right, so this is the same thing as limit as x approaches 3. Let's see, f of x, so that's just going to be negative 2. Why does it do this? Negative 2 minus x squared. There was multiple people who missed points on the quiz because they forgot to have parentheses, which are grouping symbols, to make sure you distribute the negative. The minus f of a, the f of 3 here. So I gave you a point where I want the derivative, but if I just wanted an equation using this, like you would have this whole thing with a's and you would have to distribute the negative. So that's why I say use grouping symbols. Like I'm trying to demonstrate it and show you how to do it. Okay, I want f of 3. So let me plug in 3 into my function. Negative 2 minus 3 squared, so that's negative 2 minus 9, so that's negative 11. And what do you know? Turns into positive. X minus 3. So I'll rewrite it right here. Limit as x approaches 3 of negative x squared. So let's see, this turns into plus. So plus 9 all over. Yeah, all over x minus 3. So you can plug in for a at the end, or you could do it at the beginning like I did. Because everywhere where there's an a, I plugged in 3. So limit as x approaches a, as x approaches 3. F of x minus f of a, how about f of x minus f of 3? All right. So let's see.
Factor.
Yeah?
You just take out a negative. Well, it's a perfect square. Is that the correct?
Difference of squares.
Just negative x plus 3 and x plus 3. Why'd you do that?
Okay. Do you want me to pull out a negative 1 instead? Do you want to pull out a negative 1 right here?
No, because when you cancel out, it will become negative anyway.
Okay, so I have x minus 3 on bottom, and on top I would have negative x plus 3.
Yeah.
And then x plus 3.
And then
the first two cancel, the top and the bottom cancel off and become negative 1.
Yeah.
Oh yeah, x plus 3.
Negative x.
What were you saying?
It's just negative 1, because negative x plus 3 and x minus 3 cancel be negative 1.
And that leaves me negative 1 up here. Cool. So negative 1 times x plus 3 as x approaches 3. So this turns into negative 1 times 3 plus 3. So it's just going to be negative 6.
Wait, I don't even know what x.
Isn't a 3?
Yeah.
But aren't we plugging in 3 for x?
As x goes to 3.
Oh, yeah.
Oh yeah.
How did we know that x was 3?
Let's see.
Okay, so up here so we know that a is 3, and we're saying limit as x goes to a. That means as x goes to 3. So down here, as x goes to 3, I plug in 3. Perfect. Are you ready to go on? Okay, if you're done, try the next one. Notice I didn't say you had to use the definition of limit, so that means for this one you can use the power rule. Yeah, it makes it much easier. What is the derivative? First derivative.
4x to the third.
4x to the third. 4x to the third. So wait, if I want f of 0, I just plug in, okay, we know f prime of x, we know the derivative is 4x to the third. So if I'm trying to find the derivative at 0, 4 times 0 to the third is 0. Find the equation of the tangent when x equals 0. Well, we know y of 0 is just equal to 0 to the 4th power. Well, that's just 0. What is the equation of the tangent then? So let's see, our x comma y point is 0 comma 0. Our slope is 0.
So 0.
So it's y equals 0.
Wait, don't we have to use the range? Don't you have to do y prime equals 0? Or it's just y equals 0?
Well, we're finding the equation
Oh.
of the tangent, so. You ready for this one? Okay, let's see. Y minus 0 equals 0 times x minus 0.
So frustrating.
Y minus 0 equals 0. Oh, add 0 on both sides. Y equals 0. Huh? From, we did the first derivative in part A, or sorry, number 2.
Oh, yeah.
Yes.
How do you know it's y equals 0, not x equals 0?
So, do you know what x to the 4th looks like?
Yeah.
Roughly like this. So it's at a minimum.
Oh, okay.
So Brian, on the
And we know the slope is 0 there from the derivative. So if the slope is 0, the equation with a slope of 0 would be flat, and flat would be a constant y, so y equals 0. If I have a undefined slope, it'd be vertical, so it'd be,
Okay, that's it.
okay.
Isn't the tangent the slope?
Yes.
So can't you just look at it and say, oh, the slope is 0? So that
The slope is 0, but then I said when x equals 0. I could have said when x equals 5, what's the tangent? Then you would have to find the slope and the xy coordinate, yes?
Since you know, for number 2, since you know that it's 3 times 0, could we just put it directly as 0? Or do you want us to show like...
Sean, like, all right, wait, you're asking about number 3?
Number 2.
Number 2. What about it?
Like, since we know from y equals x to the 4th equation, and since it's asking for, what is it, 0? And if we know that it's already going to be 0, do we need to, like, show work for that?
I'm confused what you're asking me. I don't understand what you're
Can
saying.
you show the derivative
Like number
of-
2.
For number 2.
Okay.
Can you show the derivative of it if we know
So
that?
if I didn't write it up here, like this, cool, show the derivative, and then you could skip this middle part, and you could go straight to saying f prime of 0 equals 0. Like this is, I want to see this.
Okay.
I want to see you find the derivative, and you plug in at the point. Cool. Yeah. Sometimes I show extra steps, but like number 2, that's all you have to show. Number 3, honestly, let's see. The things, all you have to show for number 3 is like y of 0 equals 0, y minus 0 equals 0 times x minus 0. Like, this is what I want to see for number 3. Finding the xy coordinate using point slope form. All right, if you're done, try the next one, number 4. Okay. Find the first derivative of each function. Simplify if possible. This will be fun. I'm just going to call on some people, and you're going to, like, help me out here. Let's start with Gabe. Number 4.
Take out x to the 5th. And a -2.
Okay. So -2 times 5 times x to the
X to the
4. So you're taking the exponent, bring it down, multiply by any constant that was in front, and then subtract 1. So our first derivative is just going to be negative 10x to the 4th minus 24x to the 5th. Cool. All right, next one. Let's see. Tali, what do we use here? So for number 4, we use the power rule. But for number 5, So I have two different functions being multiplied. So you could, the product rule, exactly. Exactly. All right, u prime. Let's see, u prime, the derivative would be, just a moment, 5 minus 9x squared. V prime, let's see, 3x squared minus 2. Tom?
What happens if you like multiply them?
You get the same answer.
Oh, if you FOIL?
Yeah. That would be fine. Yeah. On your homework, there was a trinomial by a trinomial. What?
Yeah.
I just did the other one.
But I mean, you will have to know product rule because it's not always easiest to multiply.
But if it was a problem like this and we did that.
If you had a polynomial, so the nice thing is since it's a polynomial, it's a binomial. That's a polynomial. That's a polynomial. By a binomial, that's polynomial. That's fine. But if you have like if you would have, if one of these, let's say the second one, if it was like sine x instead, that doesn't really help you because now you'll have to do power rule twice or product rule twice, right? So this one you'll get the same answer. I'm confident in your ability to FOIL, and then it's just like number 4. So ideally, I'd like to show you like review product rule. So u dv plus v du. Oh my god, I did it again. I'm sorry. dv and v prime are the same thing. Okay. V prime. V prime. So this is going to be 5x minus 3x cubed. So, because otherwise, like, you will have to multiply here anyway. Times, let's see, v prime, 3x squared minus 2. Add v, which is x cubed minus 2x. Yeah. Times u prime, which is 5 minus 9x squared. So, gotta FOIL both of these. 15x cubed minus 10x. I don't know why this is not showing. Oh my gosh. Minus 9x to the 5th. Plus 6x cubed. So that's this first one. Yeah. First outer, so minus 9x to the 5th. Negative 10x plus 18x to the 3rd. Yeah, I FOILed both of these. So that's that one.
Bless you.
That's that one. Cool. All right, so let's do the 5ths first. So I have negative 18x to the 5th. Is that all that really showed up? So useful. I literally put a new battery in there last week. It should be working. Fun. Okay. Okay. See, there it goes. All right. So negative 18 to the 5th. So I dealt with this guy and this guy. I don't have any fourths. I have 15x to the 3rd plus 6 is 21x to the 3rd. Ooh, plus 18, 44. 44x to the 3rd. So I dealt with these guys. Negative 10. Oh, I dealt with all the thirds. Okay. Negative 10x minus 10x is negative 20x. Okay. Ready for the other way? Or you could just straight up do the binomial, do a FOIL it. So I have 5x to the 4th. Outer, so minus 10x squared. Inner, minus 3x to the 6th. And last, plus 6x to the 4th. Okay, so this turns into y is going to be, I'm just going to write it in order, so negative 3x to the 6 plus 11, x to the 4th minus 10, x squared, and then if you do power rule, you have negative 18x to the 5th plus 44x to the 3rd minus 20x. So you get the same thing. Right. So this time, much easier. Not always. It's not easiest to just FOIL them together. Not always, but sometimes it is. Okay. Let's try next one. Noah, what's number 6? So I literally have root 3, which is a number. It's a constant number multiplied by x.
Right.
Exactly. It's just going to be root 3.
So a constant stays a constant.
So no, derivative of a constant is 0, but derivative of like 5x. If y equals 5x, the derivative would be 5.
But if it was 5x squared,
Then it would be 10x. Yeah.
What if it was root 3x?
Root of and x is inside.
Yeah.
So the exponent would be 1/2, and you'd have to use power rule.
Okay. That's
But I think we'll talk more about that in the second half.
what happens if the root is over the x?
That's what he just asked.
Oh.
Okay, so then that would be the power rule. That'd be the power rule. Because I could rewrite this as 3x to the 1/2 if it was like root of 3x. Using power rule, I take 1/2 times 3x. What is 1/2 minus 1? Negative 1/2. So literally this would just be, let's see, 1/2 times 1 over 3x to the 1/2 power. So this would be 1 over 2 root 3x. Right. So this is not going to be the level that's on this test.
nice.
But you asked what happened. I explained, asked again, and then I'll show you. Welcome. This is what happens. Are you okay?
Oh, I'm fine. I don't know what's going on. I'm like hot and cold at the same time. And like, yeah, I'm going through menopause.
Just gonna make that joke. It's like you and my mom get along. So funny. Okay.
And like the heater in my house was broken last night. So my house, I woke up and it was like 40 degrees. And I was like,
I don't have a heater. Who needs a heater in California? Okay. What do I use here?
it was cold. Well, it's cold for us because we're from California. So like, this is really cold.
I was cold.
Were you not
I was cold. Yes.
Estonian.
I
You
have
get a
multiple
little
blankets.
mini heater.
No.
Space heater. Yeah. Space heater.
Nah.
We have like 15 of them.
I have carpet in my room, and like my cat, I'm trying not to overheat him. Alright, I have x times cosecant of x. X times cosecant of x. Shh. Stop, turn around, face the front. Put your feet on the ground. Don't act like you're facing backwards. Alright, so I have x times cosecant x. This is a product. This is a product. Product. We must use product rule. So my u is x. U prime is 1. V cosecant x. V prime was the derivative of cosecant.
Cosecant cotangent. Cosecant tangent.
Yeah? Are you asking or are you telling me? Negative cosecant cotangent. Negative cosecant x cotangent.
Negative.
Like, how are we supposed to know that?
I mean, ideally, if you forget, then you could just rewrite this. What you could do is rewrite this as x over sine. And then you can use quotient rule. No, okay, let's try again. So I could rewrite this as x over sine, because cosecant, same thing as 1 over sine. And you know what the derivative of sine is. Yep, a negative cosine. So you could use quotient rule and do it this way. You could, no. Derivative of sine is cosine. Derivative of cosine is negative sine. What? No. Derivative of sine is cosine. Derivative of cosine is negative sine.
Why is it negative for one side but positive for the other?
We looked at the graph. We looked at the graphs. Yeah, the whoop-de-doops. Okay, so let's do it with the left way first, and let's do the right way, the quotient rule second. I thought we would get through this. This is taking way too long.
Is this the calculator
UV
section or
prime.
no calculator? Yes. Is calculator okay?
Where?
No, it doesn't.
What? No. It's a calculator. Yeah, didn't it? Oh no.
Oh my one. I was just
So you mean we have to use
Yeah, I was
like
looking
like 18 plus 15 plus 5?
Yeah, that's totally reasonable for you to do.
Okay. Why?
So if you're multiplying one of the things by the other, like if it's like CSC x times cotangent x, and then you have another CSC, you can't add them, right?
And then another what?
Another CSC, but it's added to the equation,
Then
you can't add it.
Nope.
Okay.
All right,
You just
V.
leave it as negative.
Cosecant. Oh, is this what you're asking?
Yeah.
So I have negative x
Negative.
cosecant x cotangent x plus cosecant x.
Why don't you make it secant or cosecant squared x?
What?
Why can't
You can't, because it's not being multiplied. It's being added.
Say the first one.
If you have x plus x, this is not x squared. This is 2x.
No, why can't that go into that and become squared?
Because you're taking cosecant of x. You can't just take things in and out of trig functions. All right, next one should be relatively fine. I'll show you the quotient rule way as well. Okay, so here's high, here's low.
Oh my gosh, I moved the call. I know, I love it.
Well, I mean, it's good for you guys because then you can see how much longer you have. And then you won't.
No, but for like tests and stuff, I always have to turn it off.
That's fine. All right, so.
Does that mean I can't be cold?
All right, so low, D high. So low, D high plus high, D low. Cross the line, square the low. So I'm showing you how to do it if you're using quotient rule. So this is literally sine x over sine squared x plus, let's see, so this is going to be, I'm going to have it be a minus x times cosine x over sine squared x. So I'm showing you get the same answer. I'm showing you if you're like, I'll remember what cosecant of x is. Convert it into sine and cosine. You know what derivatives of sine and cosine are, and you can do quotient rule. So this is the same thing as, let's see, one of the signs cancel out and I have 1 over sine x minus x times, let's see, this is, I'm gonna write it so you can see every step. Okay. So I have cosecant x minus x times, this portion right here is cotangent x. And then I'm left with a 1 over sine x, which is cosecant x. You get the same answer as over here. Cosecant of x plus x cotangent x cosecant. You get the same answer. Same exact thing.
Do you care which way it is, whether it's like positive
Well,
first or negative first?
As long as you have the right one negative.
Cool.
So, because depending if you use quotient rule or if you use product rule here, you'll get different answers. All right, number 8.
Wait, I have a quick question.
Yes.
Negative x in front of the cosecant x cotangent x?
Yeah.
Wouldn't that be -1?
No.
Oh, because we're taking.
We already took an account. I'm using the quotient rule at this point. I already took the derivatives.
Okay.
Because this is low, the derivative of x is 1, and this was the d high.
Remember 8? When you like sine.
What is the same answer as what we did before?
The answer's the one in red.
It's the same thing. All right, number 8. Sorry, is this your question?
Yeah, so.
What is sine of pi equal to?
Cosine.
Nope, cosine of pi. Sine of pi is a constant number. It's 0. What's the derivative? Yeah, sine of pi is a constant number.
It's on the it is on
It's on the y. It's 0. So this is literally sine of x minus 0. Oh, I'm literally just asking what's the derivative of sine?
Okay, perfect.
Cosine x.
Wait.
And I was like, do you need to make cosine?
Wait, why is sine of pi just?
Oh, because it's 1.
No.
Unit 0.
Sine of pi.
Yeah.
Sign of anything is 0?
Nope. Sine of pi is 0.
So, I'm gonna circle that in red.
Sine of pi is 0 because if you're on your unit circle, you're wanting the y value at pi. Surprise, the y value is 0. So that whole term goes away, and I'm just asking for a derivative of sine x, which is cosine x. All right, now we're going to do quotient rule one more time.
High D low. Low D high. All over.
Why is this not working? Is my tip broken? I think my tip is broken. Yeah, it's real funny. It's because I let students come up here and use my tablet to write answers. All right, here's my high. Here's my low. Okay.
I'm sorry, I have no filter. I don't know what's going on.
All right, what's the derivative of the high? 2. What's the derivative of the low? 2x. 2x. So,
Wait, you get rid of the
low d high, take high d low, cross the line, and square the low. What?
you get rid of like +3 and
Well, the plus 3, derivative of constant 0. So it'd literally be 2 plus 0, 2x minus 0. Low d high, take high d low, cross the line, and square the low.
Did I say that?
I don't know.
No, I probably didn't.
She got you. All right, so ready? X squared minus 1 times d high, which is 2, take, so subtract high, 2x plus 3 times the derivative of low, which is 2x, cross the line and square the low. So I'm going to simplify this a little bit. Like I'm going to simplify the top, and it would be great if like I could fully, like if there's the reason I'm not like squaring the bottom is like what if there's a factor, I could fully factor the top and cross it out. Ideally I just want you to simplify. I can definitely simplify the top.
Well, you can't.
2x squared minus 2 minus 4x minus 6x. Yeah, squared. Yeah. All right, so x squared minus 1 squared. I think I can simplify this a little.
2x minus, negative 2x squared minus 6x minus 2.
And yeah, then we won't be able
Should we leave it like
to.
that, or should we multiply everything by negative on top and multiply by 2 to the right side?
Can you take out a 2?
So if I take out 2 on top, negative 2, the top turns into x squared plus 3x plus 1. And that is not going to be any of the factors that match the bottom. So I'm just going to leave it this way.
Oh, nice.
So what I was talking about on the top, if I pulled out a negative 2, I'd have x squared plus 3x plus 1 all over. And we know that x squared minus 1 is literally x minus 1, x plus 1, but then both of these happen twice because it's squared.
Wait, you can factor that and take that out.
So, what? So I'm showing you in pink that y box the one in green. Like the top one, x squared plus 3x plus 1, you have to use quadratic equation. There's no number that adds to 3 and multiplies to 1. Like no nice integer number. So that's why I'm done. Because like I see nothing on top and bottom will cancel. So like I'm done, I'm good. Alright, well, the solutions for the whole practice test are online, as well as the review I gave you for section 3 and 4. Yeah. See you guys. So, what you have to know, what I'm expecting you to be able to memorize are product rule, quotient rule, power rule, and the derivative of sine and cosine.
Power rule is like x to the third would be
3x squared. Yep, product is how do you, when you multiply two things, how do you take derivative? Quotients when you divide them.
is the most important part of it.
So there's 5 things you have to memorize. The 3 rules and the derivatives of cosine and sine. There you go.
You beanie
Those are the 5.
You beanie person.